We're going to take a look at lesson 4.5, which covers point-slope form of a linear equation. And we're going to start right out with an example where we're looking at the population of a town. So let's read through the problem. So since the time Beth was born, the population of her town increased at a rate of approximately 850 people per year. On Beth's 9th birthday, the total population was nearly 307,650. If this rate of growth continues, what will be the population on Beth's 16th birthday? So first thing that I notice is that our rate is going to be pretty constant. So we have a constant rate, which means we can use a linear equation to represent this situation. So constant rate means linear equation. And the next thing we want to do is determine our variables. Okay, so what are the quantities that are varying? So the time is changing, right? The amount of years since Beth's birth. So let's say that's going to be X, because that's going to be our independent variable. Time passing doesn't depend on anything. It just happens. So X will be time since Beth's birth. And then the population is the other quantity that's varying, right? The population. So that will be our Y, since that is dependent on how much time is passing. Okay, and then the other piece of information that we know is our rate of change, or our slope, right? We know that the population is increasing by 850 per year. So the slope is 850, and think about it like a ratio. That's 850 people per 1 year. Okay, so we know our variables, we know our slope, and we're also given a point on this line. We're also given a solution to this equation. We're given a specific, like, time-stamped point, right? On her 9th birthday, the population is this much. So 9 years past Beth's birthday, the population was 307,650. So that is going to show up like an ordered pair, or like a point on our graph. So let's write it as an ordered pair. Remember, X comes first, and then Y, just like the alphabet. And X will be the time since Beth's birth, which would be 9. So it's going to be 9. And then the population at that point is 307,650. And I'm not going to write my comma there, because then that might confuse me with the ordered pair. So just no comma. I'm just going to write it like that, right? So any other point on the line is going to be like this, is going to be XY, right? So what we're going to do is we're going to plug in this information into our slope formula. And then that's going to help us solve to figure out what the population will be 16 years after Beth was born. So now that we have one known point, and then this is kind of standing in as our second point, general, any other point on the line is going to be in that form. What we can do is we can use our slope formula to find a linear equation. So let's remember our slope formula. Slope, which in this case is equal to, remember, 850. That is calculated by taking the change in y and dividing it by the change in x. Another way to think about it is taking one y value and subtracting another, and then doing the same thing with their corresponding x values. So since we know the value of the slope, and since we know one point, we can plug these three numbers into our formula and rearrange it in order to come up with a linear equation. So let's go ahead and do that. So again, we have 850 is our slope, and that is equal to, say, y2 minus 307,650 divided by x2 minus 9. All right, and now what we're going to do is we are going to undo the subtraction and the division going on in here in order to solve for this y value. So first thing we need to do is we need to undo this division. We need to undo the division. So that's going to require us to multiply by the number down here in the denominator. And in this case, it's not just a number, it's an expression. So I'm going to multiply by this x2 minus 9. So multiply by x2 minus 9. And if I multiply this side by that, that means I also have to multiply this side by that. These guys will cancel out, and I'm left with, let's rewrite it, 850 times x2 minus 9 equals y2 minus 307,650. Now we need to undo that subtraction. So we undo subtraction by addition. So I'm going to add 307,650, which means I also have to add it over here. And then these cancel out, and I'm left with just y equals 307,650 plus 850 times x2 minus 9. That got kind of messy. Let me rewrite that. And I'm going to rewrite it so that the y comes first and then the expression is on the right side of the equal sign. I'll do that right here. And I'm also going to just take out this y2 and the x2 and just leave it as just x and y, just to make it a little cleaner. So I'm going to do y equals 307,650 plus 850 times x minus 9, right? So this is now a linear equation that I could put into my graphing calculator or into Desmos, and I could plot it on a coordinate plane, and it would show me the population in Bethstown over time. I want you to notice that right here is that x coordinate of our one known point. So that's our x, or our y coordinate, I'm sorry. That's the y coordinate. Right here is our slope. And then right here was our x coordinate, right? Right, and now let's answer this question from up here. What will the population be on Beth's 16th birthday if the population continues to increase at that rate? So remember, remember that time since Beth's birth is represented by x, by the variable x, and y was the population. So if I'm looking for the population on Beth's 16th birthday, that means I'm going to plug in 16 for X. Then I'd solve for Y, and I'd be able to find the population. So let's go ahead and do that. Do 16 in place of X here. So I get Y equals 307,650 plus 850 times 16 minus 9. So Y, which remember is our population, Y is equal to 307,650 plus 850 times 16 minus 9 is 7, right? Yes. So I'm going to pull out my calculator, and I'll go ahead and put that in. So I have 307,650 plus 850 times 7, which is equal to 313,600. So that's going to be the population on Beth's 16th birthday, right? And so what we're going to be talking about, like I mentioned, is point-slope form of a linear equation. So far we learned intercept form and we learned slope-intercept form. Point-slope form is just another way of writing a linear equation. And it's going to be in this form right here. And I have a more general version of that on the next page. Yeah. So what it's saying is that if a line passes through a point x1, y1 and has a slope of b, the point-slope form of the equation is y equals y1 plus b times x minus x1. So again, we saw on here, we looked at this, we had y equals the y coordinate plus the slope times x minus the x coordinate. Okay, so point-slope form is really useful when you know the slope and when you know a point on the line. All right, and so let's look at how this shows up on a graph. Right, so we have, again, y equals y1 plus b times x minus x1. Well, this x1, y1 is right here, is a point on our line. And then the slope, again, is the change in y over the change in x. So just the rise over the run. Rise over run. And again, this y coordinate of this point here shows up right there. The slope is showing up right here. And then we have x minus the x coordinate. So we're going to get some practice. We're going to write some equations in point-slope form for a line given its slope and one point it passes through. So again, I have my equation written here in point-slope form. Y equals y1 plus b times x minus x1. So again, this x1 and the y1 are my x and y coordinates of my point. Remember, x and y. And then this b right here is my slope. So let's give it a try writing this equation in point-slope form. So I get y equals, always start like that, y equals, then y1, so that's going to be my y coordinate of my point, so it's going to be 5, plus my slope, which is 3, times x minus my x coordinate, which is 2. And that's that. Let's try the next one. Y equals my y coordinate, which is 0, plus my slope, so plus -1 times x minus the x coordinate, which is 3. We can rewrite this, we can simplify it a little bit. So if I just have 0 plus something, that 0 doesn't really count, right? It doesn't really do anything, so I can just kind of get rid of it. So instead of 0, I'm just going to write this piece. And instead of saying -1 times this, I can just say negative x minus 3. And that would still be in point slope form. And then let's try one more. We have a slope of 0 and a 0.37. So again, I'm going to write y equals the y coordinate, so that's 7, plus 0 times x minus the x coordinate, which is 3. So y equals 7. And then over here, that 0 times x minus 3, well, anything times 0 is just 0. So that's just going to turn out to be 0. So then my formula is y equals 7, which means that is a horizontal line. All right, so now what I want you to do is go back through your notes, check to see if you have any questions, and if you do, please let me know. And then go check out the practice problems as well as the check for understanding in Google Classroom and get those completed. And again, any questions or if you get stuck on anything, just let me know. All right, thanks for watching. Hope you guys are having a great day.